For hyperbola, 4x squared minus 5y squared equals 20, and a line passing through point A, which is 3, 0, and intersects the hyperbola at P and Q. For point B, negative 3, 0, the perimeter of triangle PBQ of the triangle is 12 square root of 5. We're going to find the length of PQ. So that's a little lot there. I did little diagrams, so let's write this in standard form. So basically let's divide 4x squared minus 5y squared equals 20 and divide everything by 20. So it's going to give me x squared divided by 5 minus y squared divided by 4 equals 1. And let's figure out our A. Our A is going to be square root of 5. Our B is going to be square root of 4, which is 2. And our C, that's going to be A squared plus B squared, which equals 5 plus 4. So square root of 9 is 3. So your C is going to be, C squared is 9. So C is going to be plus and minus 3. So the foci of our equation is going to be, since x is the lead here, it's going to be on the transverse axis, is going to be the horizontal axis. So we have 3, 0, that's F, and negative 3, 0. So that's these points here. This is going to be 3, 0, and this one right here is going to be negative 3, 0. All right, since A and B are the foci, because they gave us the A and B here, and they happen to be the same as our foci, by definition of a hyperbola, this BP, and I'll do this in white, this PB here, minus PA equals 2A. So when you take these two and subtract, you get 2A. So we're going to do the length of PB minus the length of PA equals 2A. So that's going to be, my A is square root of 5. So that's going to be 2 square root of 5. Same thing for this one. This length here, QB, I'll do it in purple now, QB minus QA, this one right here, is also 2A. So we're going to write this as QB minus QA equals 2A. That also equals 2 square root of 5. Now I'm going to call this equation 1 and this equation 2. And I'm going to add these two together. So when you add these together, what you're going to get is P, B, B, then add this one plus QB, then we have this minus, so just put minus, then add these two, PA plus QA, and then when you add these two, you're going to get 4 square root of 5. All right, now if you notice this one right here, PA plus QA, this one, that's going to equal PQ. And we need to get that in there because that's what we're trying to find. So now I can write this as PB plus QB minus PQ. Finally, we have something in our equation equals 4 square root of 5. All right. Now I'm going to write that down again. We have PB plus QB minus PQ equals 4 square root of 5. I'm going to call this equation 3. And it's also given that the perimeter of our triangle is 12 square root of 5. So here's our triangle, PBQ. So it's right here. I'll put it in white. So this is our triangle right here. Now, so that means we have PB plus QB plus PQ, that equals 12 square root of 5. Because that's given here is 12 square root of 5 right there. All right, now what we're going to do, let's call this equation 4. Now what we want to do is take equation 4 and subtract equation 3. So I'm kind of going to work backwards here. So PB's will, so if I have PB minus PB, that's going to be 0. QB minus QB is 0. And then this one, when you add those up, you're going to get plus 2PQ. And that's going to equal, when you subtract these two, we're actually subtracting. So this would be PQ minus a negative PQ. So that's what gave us the plus. So when you subtract these two, you're going to get 8 square root of 5. Now all we have to do to solve for PQ is divide both sides, so we don't need the zeros there. So our PQ is going to equal 4 square root of 5. And that's it. Thank you. Have a nice day. Bye-bye.